Chapter 1.6 is on inequalities. Inequalities occur when the equal sign is replaced with an order sign, and the order signs are greater than, less than, greater than or equal to, less than or equal to, which says that the two sides are not necessarily or cannot be equal to each other. And when you do inequalities, when you solve them, because there are often infinite solutions, you express the solution as a graph. So let's consider the equation of 3x minus 5 is less than 16. So you do is you solve it the same way as you do an equation. So you add both sides by 5, so 3x is less than 21, so x is less than 7. However, when you graph it, you have to mark 0 and 7, and there's an open circle in 7, and then the arrow goes out. And that is your solution to the inequality. And I will explain why I use an open circle on the next slide. So you use an open circle in your graph when the endpoint is not included. And the endpoint is not included when you have the order signs of less than or greater than. You use a closed circle when the endpoint is included. And that occurs when you have the order signs of less than or equal to or greater than equal to, because the solution could equal that point that's being used. So let's consider the two equations of x is less than 7 and x is less than or equal to 7. So this is what we've done on the previous slide. So it's 0 and 7. It's an open circle because it's less than, and then the arrow goes out. On this one, however, it is less than or equal to. So you would put a closed circle on 7, and the arrow would go out the same way. So the only difference between the two graphs is the closed circle versus open circle. So let's consider the equation of negative 3x is greater than or equal to 18. So you divide by negative 3. When you divide by a negative number, you have to remember to flip the sign. So you would have x is less than or equal to negative 6. And so then you can label your points, and it's a less than or equal to, so it's a closed circle. So an interesting thing occurs when you have absolute value signs. So the absolute value of x is greater than 9. So that means that either x is greater than 9 or x is less than negative 9. Because imagine you had a number of, say, x equals negative 10. The absolute value of negative 10 is 10, and so it satisfies the equation. And so when you graph it, you have your 0, and you have 9, and negative 9, and the equations go up and out, and it's open circle because it's less than and greater than. So that's what happens when your absolute value is greater than number. Absolute value of x is less than 9. You know that x is less than 9, or x is greater than negative 9. However, if you look at this solution, the two graphs close the area. So it's not an or, but it's rather an and this can be as negative 9 is less than x is less than 9, which is the same equation, just rewritten. So with absolute value can be written uniquely. So if you imagine that n equals an expression and c is greater than or equal to 0, then if you have the absolute value of n is greater than c, you know that n is greater than c or n is less than negative c. However, if the absolute value of n is less than c, then you know that negative c is less than n is less than c, which allows you to write the inequality much simpler. Let's solve these two equations. 2 minus 6x is less than or equal to 8. So you subtract both sides by 2, so you get negative 6x is less than or equal to 6. X, remember, flip the sign, greater than or equal to 1. So you have your 0 your -1, your solid circle, and it goes out. And with this expression, the absolute value of 4x plus 2 is less than 9. Because it's a less than, you can rewrite it quite easily with -9 is less than 4x plus 2 is less than 9. And so when you subtract, you can start all three sides by -2. So you get -11 is less than 4x is less than 7. When you divide by 4, so you get -11 fourths is less than x is less than 7 fourths. So you have your 0, your 7 fourths, and your -11 fourths with open circles on both endpoints that go in and connect to each other. And that is inequalities.